Let's go over the AltaSQL workflow for generating and using generated select statements. We will demonstrate this shortly in a hands-on demonstration. The first thing we have to do is define the repository context. This requires setting the context session variable sBuilder_meta repository to the desired repository. This tells AltaSQL which repository to use when executing AltaSQL functions. Copy the sbuild repo session variable function from the ready to execute spreadsheet. Edit and execute the function call, which produces the appropriate set statement, setting the sbuilder meta repository session variable to the fully qualified repository name. Execute the resulting set statement. Copy and execute the resulting set statement in other worksheets as needed. If needed, you can search the repository for the name of the desired object. You can also search for column comments and other metadata. Copy the sbuild select function from the ready to execute spreadsheet. Edit and execute the function call. Copy, paste, and format the resulting select statement into a desired worksheet. Examine the statement before executing. No wasted credits or efforts. Set the appropriate warehouse and role. Comment, edit, delete, or add lines from the generated statement as desired to rename, exclude, replace, or add columns, which we will demonstrate in the demo. So let's jump into the hands-on demo. We've already done a little setup. We have a little script that'll save you watching me type. We've logged into both of our worksheets, and we've set both worksheets to use an extra small warehouse, which we call Tiny. The first thing we need to do is to be able to tell all of these AltaSQL functions which repository to use. We do this by setting a session variable, which we will refer to as the repository context. We generate this statement from one of our AltaSQL functions, which I have already copied from the Excel spreadsheet into the worksheet, and currently it is highlighted. We tell the function which database the repository is located in, which schema, and the name of the repository table. So let's go ahead and execute the function. And now what we do is we copy and paste it, and we execute it. So now that we have set up our working environment, let's see what all the view definitions are in the repository. We'll highlight this statement, which tells us that we're going to search the repository for the view definition names. And you will see that the view definition names represent all of the tables that are in the Chinook database physical schema. As we've mentioned, you can search the repository with standard SQL. So let's simply get all of the columns for the customer table and see where they live. In this particular case, since we're just dealing with a single object, all of the columns can be found in the source database, the source schema, and of course the table. So now that we've done that, we want to actually generate the select statement. Again, we copied and pasted the function from the spreadsheet. We simply left off the optional arguments because we won't be using them. We have the statement. We copy and paste it. We copy and paste it into our worksheet. We format it. And let's execute it. And voila, we've generated a new form of Select Star that, as we will see, is much easier to use
than the standard Snowflake Select Star. So let's start doing some work on this. But before we do that, just ask yourself a couple questions. How would you get the equivalent in Snowflake starting from scratch? Once you have it, where and how are you going to save it? Of course, it's always available from SnowBuilder. So let's add a limit so that we don't have to see and constantly look at all the data. We'll add limit 10. We'll execute it and see that we only get 10 rows back. Let's do order by. We would like to order it by the last name. Now we could either try to type in last name, which since it's in camel case could almost certainly result in an error, or we can simply copy and paste it. And execute. Now we see that everything is ordered by last name. Now let's remove a column. We don't really need the support rep ID because we're not going to be looking for support. All we have to do is in Snowflake, where if you were working with a select star, you would have to type in remove and the name of the column. So now you probably can't see it, so we'll need to scroll. There's no rep ID column. Now let's change the customer ID column and call it account number instead. I'm just going to copy and paste this so you don't waste time watching me type. I didn't quite do it all correct, so let's put in the quote. Let's execute it and see what happens. So now you'll see that we have account number instead of customer ID. Note again how we generate the select statement as column aliases. Now let's add a where clause and filter on country equal to USA. Where, and let's cheat and once again copy and paste the column name because it could have been something much longer. And put in USA. And now you know why I seldom do live demos in front of an audience. But you will see that the country is now all USA. Now let's remove some more columns. We want to get rid of all the contact information. So instead of having to type it in, we simply comment it out. Execute. Now you will see that we've removed a lot of the contact information. We want to get rid of address, so let's go ahead and get rid of that too. Now ask yourself how much effort you would have to put in to do these same queries using Snowflake's and Select Star. So now let's do one more thing. Let us count the number of customers by country. We're going to cheat and use DB Visualizer to comment everything out rather than typing it. So we'll comment the block, and then we'll simply comment out the postal code. We're going to get rid of order by last name, count. So going to add the group by. Let's see what we get. $13. Well, we didn't really want USA, so let's get rid of this. So let's order the results by the count in descending order. And voila. Cut. So now you can see how SnowBuilder's replacement for Select Star lets you work and discover the data in your existing objects much quicker and much faster with much less frustration, far fewer keystrokes, far fewer handwritten queries, and probably a bit less frustration.
Let's recap what we did with AltaSQL's version of Select Star. We ran 8, or maybe it was 9, I lost count, distinct queries by simply editing the original statement. No need of Snowflake's rename, exclude, or replace features. We did this with minimal keystrokes. We copied and pasted the existing column names from the generated text. We did not need to retype them. The generated source columns were fully qualified and properly quoted. The column aliases were properly quoted. We generated a fully qualified from clause. AltaSQL provides many options for qualifying columns. We will discuss that in later videos. AltaSQL select statements are easily edited to rename columns, exclude columns by simply commenting them out, add or replace columns including expressions, reorder by copying and pasting, and we could add post from clauses. To repeat, this functionality is immediately available when creating a repository from the Snowflake information schema, providing immediate gains in productivity. Repositories are typically created from and include all views and tables in the desired schema. Other objects may also be included. AltaSQL's replacement of Select Star improves productivity starting on day 1. AltaSQL's replacement of Select Star improves productivity starting on day 1. So